Hello, everyone. Thanks again for joining today's webinar. Uh, as mentioned in the announcement, today's webinar uh, consists of three main parts. The first part will include the P.Eng licensure in Ontario, and the second part will be a mini lecture on electrical engineering course A1, and the third and last part will be a mini lecture on the complementary studies CS1 course. So I'll start now with presenting the P.Eng licensure in Ontario. Let me share my screen here. You see my screen?
Yes, yes, we can see it.
Okay, perfect. So let's start. Uh, So actually becoming a licensed engineer in Ontario not only validates your skills, but also opens up leadership opportunities and enhances your career prospects. Today, we're going to talk about the P.Eng licensure process in Ontario. This is a critical milestone for engineering graduates. The process involves several steps, starting with academic qualifications, completing the required work experience, and passing the technical exams. So today, I'll walk you through the steps of obtaining this prestigious designation, address some common challenges that candidates face, and explain how P.Eng Academy is here to help you succeed. So first of all, let me introduce myself. My name is Mohsen Khalaf. I'm a co-founder of P.Eng Academy, along with my two friends, Muhammad Hamouda and Abdurrahman Ayad. Both friends, the three of us are PhD holders from Canadian universities. A little bit about myself. I graduated from Asit University in Egypt in 2012, and I was on the top of my class. I was hired at the same university as a teaching and research assistant, and I worked there between 2012 to 2016. During this time, I got my Master's of Science in Electrical Engineering. Next, I traveled to Canada in 2016 to start my PhD journey at the University of Waterloo. I finished the PhD journey in 2020. Next, I worked as a postdoctoral fellow at the University of Toronto between 2021 and 2022. My PhD research and my postdoctoral fellowship research focused on the cyber-physical security of power systems, and I worked in collaboration with Hydro-Quebec in the province of Quebec in order to investigate the cyber security of their systems and propose solutions for them. I also worked as a part-time lecturer between 2021 and 2023 at the University of Waterloo and at Conestoga College in Ontario. I received the P.Eng license in 2023, and as of 2022, like starting from 2022 and up until now, I work as a power system engineer at the ISO. Let me now introduce P.Eng Academy. Our mission is simple. So we aim to support engineering graduates in Ontario in achieving their professional engineer designation. The process of becoming a P.Eng can feel overwhelming with its technical exams, competency assessments, and application requirements. That's where we come in. At P.Eng Academy, we break down these complex steps into manageable milestones, providing the tools, resources, and guidance you need to succeed. We're proud to offer tailored courses in core engineering disciplines, practical workshops, and one-on-one mentorship to ensure that every candidate is fully prepared. Whether you are just starting the licensure process or tackling a specific challenge, P.Eng Academy is here to help you reach your goals and elevate your career. Whether you are preparing for technical exams, drafting your experience record, or needing clarity on the licensing process, we are here to ensure you are equipped to success. And you can reach out to us through our website, Facebook, or LinkedIn links here. In Ontario, the P.Eng designation is a mark of professional excellence, credibility, and trust. It also opens doors to engineering roles, increases earning potential, and is often a legal requirement for engineers signing off on projects. In this webinar, actually, we're going to, on this first part of the webinar, we're going to talk about the P.Eng requirements in Ontario, the P.Eng path, and how can P.Eng Academy help and support you. Let's start with an overview of the steps to become a professional engineer in Ontario. Number one, the academic requirements. You need a degree in engineering from an accredited program in Ontario. Number two, the NPPE exam, or the National Professional Practice Examination. This is a key requirement, testing your understanding of ethics, law, and professional practice. Number three is the work experience, where you must complete 4 years of work experience under the supervision of a licensed professional engineer. Number four, the technical exams. This may be required depending on your academic background. And finally, number five is the competency assessment. You will demonstrate your skills and experience through detailed competencies and submit an application. Each step of these steps has its own challenges, but with proper guidance and preparation, they are completely manageable. P.Eng Academy is here to ensure you are confident and prepared every step of the way. One of the first steps to becoming a professional engineer in Ontario is meeting the education requirements set by Professional Engineers Ontario, or the PEO. Let me break it down for you. If you hold a bachelor's degree in engineering from a program accredited by the Canadian Engineering Accreditation Board, or the CAAB, you meet PEO's academic requirements automatically. This makes the process smoother for Canadian graduates. If your degree is from a program on the PEO's recognized programs list, you may still meet the academic requirements, but you might need to complete a set of technical exams to fulfill any gaps compared to the CEAP accredited standards. For graduates with engineering degrees from outside of Canada and the USA, PEO requires a course-by-course report from the World Education Services, or what is known as WES. This evaluation determines how your education aligns with CAAP standards and identifies whether any technical exams are required. If there are any gaps between your academic background and the CAAP standard, PEO will assign you technical exams to address those gaps. Successfully completing these exams will fulfill the academic requirements. Finally, for individuals without a bachelor's degree in engineering, PEO offers a limited license option. This allows you to practice professional engineering within a clearly defined scope. It's a great pathway for those with related qualifications or extensive experience in specific fields of engineering. At P.Eng Academy, we understand that meeting these academic requirements can be challenging, especially for international graduates or those assigned technical exams. That's why we offer targeted support, from exam preparation to guidance on the WES evaluation process, ensuring you are set up for success. Let's talk about technical exams now, which are an essential step for many applicants pursuing their P.Eng designation in Ontario. If your undergraduate degree is not accredited by the CAAP, you may be required to complete a technical exam program. These exams ensure that your academic qualifications align with the standards set by PEO. Here is how the technical examination program is structured. You take 4 exams in total, 2 exams from Group A. These 2 exams cover core engineering topics within a specific discipline. 1 from Group B. This is a more specialized and allows some flexibility to align with your area of expertise. and one complementary studies exam, which focuses on non-technical areas like economics or management, engineering economics or engineering management, which are also critical for professional practice. The pass mark for all PEO exams is 50%, which is achievable with the right preparation and focus. Now, I know these exams can feel intimidating, especially for international graduates or those who have been out of school for a while. That's where P.Eng Academy steps in. We offer comprehensive preparation courses tailored to the PEO exam format. Our goal is to equip you with the knowledge and confidence you need to succeed on your first attempt. At the end of the day, these exams are an opportunity to deepen your expertise and demonstrate your readiness to join Ontario's professional engineering community. Next here, the National Professional Practice Examination, or the NPPE. This is a critical step in the licensing process. It's a 2.5 hours closed book online exam that tests your knowledge of ethics, professional practice, engineering law, and professional liability. These are all essential areas for practicing as a professional engineer in Ontario. You typically have up to 3 attempts to pass the exam. However, it's important to meet the timeline set by PEO, as the NPPE must be completed within the time frame specified to keep your application on track. PEO will inform you of the deadline for your exam. Completing the NPPE remotely ensures your application can be proceeded within 180 days, including time for exam evaluation. Lastly, you are eligible to take the NPPE exam once PO confirms your application is complete. So make sure all your documents are in order. Now we'll talk about the experience. This is an important step as well. An important update here is that P.Eng licensing process in Ontario no longer requires Canadian-specific experience. This is actually a great news for international applicants. However, all applicants must still fulfill 48 months of acceptable and verifiable professional engineering experience. This experience demonstrates your ability to practice engineering at a professional level. To assess this, PO uses a competency-based assessment, or what is known as the CBA model. The CBA evaluates your engineering competencies across key categories essential for effective practice and public safety. This shift to a standardized model ensures that everyone, whether trained in Ontario or internationally, is assessed fairly based on their skills, knowledge, and readiness for licensure. Becoming a P.Eng is an exciting but challenging journey, and many applicants face challenges along the way. Here are some of the most common challenges that the candidates face. First of all, the licensure process can feel overwhelming due to its multiple requirements and steps. Knowing where to start and staying on track is very important. Next, developing a structured study plan and allocating sufficient time to each topic is key. Participating or practicing with previous exams is essential to familiarize yourself with the format and question styles. Time management also can be a struggle, especially for those working full-time while preparing for exams or meeting other requirements. Having a mentor can provide invaluable support and advice, but finding one who understands the process and your specific needs can be difficult. Meeting the experience requirement, especially in specialized fields or industries, can take time and effort. Next, documenting your experience in the CPA format requires careful thought and understanding of PEO's expectations. In addition to this, the ethics and law-focused NPP exam is another important milestone that demands effective preparation to pass within the allowed time frame. These challenges highlight the need for a structured approach, reliable resources, and the right support system to succeed in the licensure process. One more challenge here is to be up to date with the new programs that PEO offers. For examples, a couple of weeks ago, Ontario shed the light on the probability of having the EIT program back to the province of Ontario. So actually, staying up to date is very important. All you have to do to stay up to date is just to follow our social media and LinkedIn page to be up to date. So at P.Eng Academy, we have designed our services to address these exact challenges. This is a highlight of our services here. We provide a comprehensive technical exam preparation courses in 3 engineering disciplines. Our courses are designed and taught by experienced instructors who understand the process firsthand and have proven teaching experience. Our expert mentors are available to guide you through every step of your preparation, offering personalized advice and assistance. We also host regular workshops and webinars focused on critical topics to deepen your understanding and reinforce key concepts. This is our second webinar. We had our first webinar in December, and at that webinar, we promised to have a second webinar, and we have regular webinars, and here we are having the second webinar here. So from navigating the application process to guiding you through the competency-based assessment experience report, we ensure you are supported every step of the way. So choosing P.Eng Academy means having the right tools, guidance, and support to achieve your goal of licensure. This is a highlight of the courses that we offer in P.Eng Academy in 3 engineering disciplines. In electrical engineering, we have 3 Group A courses and 1 Group B courses. In mechanical engineering, we have 3 from Group A and 1 from Group B. And in mechatronics engineering, we have 4 courses from Group A and 1 course from Group B. And we also, from the complementary studies group, we have 1 course that all the engineering disciplines can take. As you can see here, although that in the exam, you need only to take two courses from Group A, we offer more than 2 courses for each engineering discipline to give you more flexibility in choosing your courses. This slide here shows the prices of our services. So if you're going to take 4 technical exams, this is going to cost you 1,800s. If you're gonna take less than 4 technical exams, it is $500 per course. The average hours of the course is 20 hours. We start our courses, for example, for May sitting, we will start as soon as February, the first week of February. And we also, like, spaces are limited, so you need to book as soon as possible. Our groups, we have small groups of maximum of 6 candidates or 6 engineers for every course. So we have very limited spaces, very limited spaces. We also offer 4 courses plus CPA consultation for $2,000. And if you're looking for CPA consultation plus feedback, we offer this for $300. The general consultation is $50 per 30 minutes. So for now, as of now, we have 15% off discount on the courses if you take courses, like if you take the 4 courses only for May exam settings. You need to book by January 31st to get this discount. We also promised a special discount or special promotion for the webinar attendees. So in addition to having a 15% off our technical courses, we also offer 15% off any other service, like reviewing the CPA, and we also offer the consultation for free for now. We also offer review the CPA for free with the booking of any 4 courses. And there's also 1 week special that ends on January 24th. We can do the CPA consultation for free for anyone, even if you don't book any course. So it's your turn now to take the first step toward your P.Eng designation. You need to register with P.Eng Academy and let us guide you to the success. Thank you. This is it about the first part of the lecture. You can reach out to us through our website, Facebook, LinkedIn, or email, or you can call or WhatsApp this number. Thank you, and I'll open the floor now for questions. So we have very limited time for questions. So just to leave some time for the second, third part of the lecture. Any quick questions? We will also have a chance to ask questions at the end of the webinar. You can ask your question or type it in the chat. Okay, we can keep the questions after the third part of the webinar, and we can now start the second part. It's a mini lecture in electrical engineering discipline courses. It's course A1. I'll turn it over now to Dr. Muhammad.
Thank you, Dr. Mohsen, for this introduction. So, share my screen. So please let me know whenever you see my screen.
We still don't see it. Yeah, now it's good.
Okay, perfect. Okay, hello everyone. So welcome to this mini lecture. So my name is Mohammed Hamouda. I am also a PhD holder from University of Waterloo. And today I'm gonna discuss with you the Thevenin's theorem. So the outlines of this lecture will start with objective. What is the objective we have in this mini lecture? And then what is the motivation of using this Thevenin's theorem? And then we'll talk about the theorem itself. After that, we'll give you some examples. And at the end, there will be a take-home note. So the objective of this lecture is to understand first the motivation of this theorem. This is the first thing. This is the most important thing. And then to understand how to calculate or how to get the equivalent Thevenin's model, which is R Thevenin or Z Thevenin and V Thevenin, as we will talk in a couple of slides. So these are the main objectives we have in this lecture. For the motivation, Thevenin's theorem could be used to simplify any linear circuit. So for example, here, if you have this linear circuit on the left-hand side, this circuit could be simplified using Thevenin's theorem to a Thevenin equivalent model, which is V Thevenin and Z Thevenin. So this is basically why we use this Thevenin's theorem. For the theorem itself, Thevenin states that any linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source V7 in series with an impedance Z7. So, as we mentioned before, the 7 equivalent will be V7 and Z7. This is the general model that is an AC circuit. In DC, we don't have the reactance part, so we have only V7 and R7. V7 is the open circuit voltage at the terminals that in the main circuit. So coming back here, V7 will be the open circuit voltage calculated between these two terminals A and B, and Z7 will be the input or equivalent impedance as seen by these terminals. So in order to calculate Z7, we need to calculate Z7 as seen by these terminals. So let's take an example to understand how to calculate this model. In this question, we need to find the 7 equivalent circuit of this circuit, and also to find the current through this resistance, this variable resistance, when its value is 6 ohm. So let's first recall the theorem. We need to calculate two things here, V7 and R7, because this is a DC circuit. And to calculate V7, we need to calculate the open circuit voltage between the terminals. And to calculate the R7, we need to calculate the input resistance when all the independent resources are turned off. So we need to turn off all the independent resources, and then we calculate the input resistance as seen by these terminals. So let's start with V7. So to calculate V7 in between these two terminals A and B, I will remove now the load here, which is RL, and this will be the equivalent circuit here. And then I will utilize mesh analysis. In the main courses, we'll talk more about the mesh analysis, the nodal analysis, and all other analysis that are useful to help solving these 7 circuits. But in this case, I will use mesh analysis. And for mesh, we have to assume mesh current. So we will have mesh current in this loop and another mesh current here. This one is I1 and this one is I2. These are the two mesh current that we have in this circuit. And after that, we need to write down the KVL equations for each mesh. So for mesh number 1, I will start with a point and then I will go in a loop until I will come back to the same point again. So the KVL for this mesh will be negative 32 and then positive 4I1 and then positive 12 times I1 minus I2. And then I'm back at the same point. So that's it. In the main lectures, we will talk about how to write these KVL equations at the beginning of the course. And for the other mesh, we have something called dummy mesh because we have a current source here. So we have I2 equal to negative 2 amps. And then solving the first equation here, you can get the value of I1. But now, how can we utilize these values actually to calculate V7? So to calculate the voltage between any terminals, you need to move from the positive terminal to the negative terminal, summing all the voltage in the way. So you have 3 options here. Either you go through this way or through this way here, or through the largest loop. So the first one here, we don't know the voltage across the 2 amps. So this is a bad idea to use this as a way to calculate the V7. So I will utilize the other loop. which will be this one here. So moving from the positive terminals, here we have a voltage drop of 0 because we don't have any current. Then we have 12 ohm multiplied by I1 minus I2, and then we are back at the negative terminal. So V7 will be 12 times I1 minus I2, which is 30 voltage. So this is how to calculate V7. Any questions so far? Any questions? Okay, perfect. So we can continue. So the next part is to calculate R7. So to calculate, oh, before that, you can recalculate V7 using another techniques like nodal analysis. So I prefer retry to solve this question using nodal analysis to calculate V7. So for the next part to calculate R7, we need first to deactivate all the sources. So the current source will be open circuit, the voltage source will be short circuit. So you have here 4 ohms parallel with 12 ohms, then in series with 1 ohm, then the equivalent R7 will be 4 ohms. So the complete model now will be V7 and R7. So we have R7 of 4 ohms, V7 of 30 voltage. Then this is connected again to that load in this case. And in our scenario, have RL equal to 6 ohm as stated in the question itself. So we have 6 ohms here and here 4 ohm. Then the current in this loop or in this single loop will be 30 voltage over 4 plus 10, which is, sorry, 4 plus 6, which is 10. Then the current will be 3 amp. So this is an example of how to solve 7 circuits. The other example we have is to find 7 equivalent of this circuit. And for this one, I will solve only V7. And how to, in order to calculate R7, we'll talk more about that in the main lecture. So I'll do the same. I will assume mesh currents, and then here we have dependent source. We have dependent source of 2Vx, and Vx is the voltage across these 4 ohms. So Vx in our scenario equal to 4 multiplied by I1 minus I2. So we write down the KVL equation for the meshes. First, we have I1 equal to 5 amp. This is a dummy loop because we have a current source here. And then we have a KVL equation for mesh number 2. And you can use the same technique as previous to write the KVL equation. And finally, the KVL in mesh number 3. And we don't forget that Vx again is equal to 4 I1 minus I2. So you can substitute that here and solve these to get I2 and I3. But the main goal is to calculate V open circuit here, or V7, which is a voltage, open circuit voltage between these terminals A and B. So we need to move again from the positive sign to the negative sign, summing all the voltage in the way. So the shortest way is this small, or this short way here. So the voltage V7 will be the voltage across this resistance plus the voltage across this resistance here. We don't have any current moving in the 2 ohm resistor, so the voltage drop will be 0. And the voltage drop across this resistor will be 6 multiplied by I2. So we need only to calculate I2 to get this V7. So V7, again, It's equal to 6I2, which is equal to 20 voltage. Now, to calculate R7, it's a tricky part. We can discuss this in the main lecture because we have a dependent source here. We cannot deactivate this dependent source. We only deactivate the independent sources. So we'll talk more about that during the main lecture. Any question? Any questions so far? Okay. So this is an example from the previous exams, BO exams. The requirements are to find the Thevenin equivalent V7 and Z7 between the terminals A and B, to calculate the load across A and B for maximum power dissipation, and we can discuss this more in the main lectures, and also to calculate this maximum power dissipation in this load. So for these parts here, C and B, I don't know why they switched that. So this should be B and this should be C, but anyways, so we'll talk more about this in the main lectures. But I will discuss with you only how to calculate the Z7 for this question. So to calculate that, we have this circuit here, and to calculate the Z7, we need to deactivate all the independent sources. So we will deactivate this guy here, this voltage source, which will be short circuited. Then we'll have this circuit. And now the question is how to calculate the equivalent impedance as seen by these two terminals. And I found that the easiest way to do that is to change the way or change how you draw this circuit. So I did this trick here to change the terminals. I didn't change anything. I just changed the way or the drawing of the circuits. And then I did this trick here to take this circuit or this connection from this big loop to be here. It's exactly the same circuit. I didn't change anything. Now it's clear that the the impedance between A and B is equal to 2 ohms parallel to J10 in series with 6 ohm parallel with negative J50. So Z7 will be equal to, in this case, to 7.8 minus J 0.325 ohms. So this is one of the examples from the lecture. In the main lecture, we'll talk more about, we will take another examples from the previous exams. For the take-home notes, again, Thevenin theorem is used to simplify the circuit to be a voltage source in series with impedance. And this theorem is applicable only for linear circuits. To calculate V7, we need to calculate the open circuit voltage between the terminals. And to calculate Z7, we need to calculate the input impedance when all the independent sources are turned off or deactivated. And these are the references for this mini circuit. Thanks, and any questions? Questions?
Actually, Dr. Muhammad, I have a question on the circuits exam. So,
Yes.
based on your experience, is the level of difficulty, is it the same as we have seen in example, or is it more difficult or less difficult from your experience with the previous exams?
No, I see that the level of difficulties is the same, actually. So PO gives only the exams from 2013 to 2019. And the level of the difficulty is almost the same. So you will see almost similar questions. It's not exactly repeated, but in the same level. So understanding the, the theorem and understanding the basics of these question will help you to solve any exam. So I don't see that they change the level of difficulty that much.
Okay, thank you.
Okay. Any other question? Okay, so to you, Dr. Abdurrahman.
All right. Thank you to Dr. Muhammad and Dr. Mohsen on the presentations. Um, let me get started. Let me share the screen. Okay, can you see the correct screen?
Yes.
Okay, perfect. All right, so thanks everybody for staying so far. I know we've been about 40 minutes in the session, so I'll try to keep it short. Um, my mini lecture today will be on the CS1 Engineering Economics, which, as Dr. Mohsen has explained, is part of the complementary studies, which means that if you are taking the electrical engineering path or the mechanical, environmental, civil, all of these you can take the engineering economics, which I think underscores how relevant it is to all domains of engineering. So my name is Abdul Rahman, and I am electrical engineer by training. Uh, but today we'll discuss some fundamental concepts about the engineering economics. So as I mentioned, it's a complementary studies exam, and it tests several key concepts, which I think are very relevant to all engineers in their daily practice. So what's very interesting about the engineering economics is that when I teach the course to engineers have already graduated and have taken the course already in their undergraduate studies or even in their graduate studies, they often have a different perspective on the engineering economics. And the reason is if you take the material itself and learn it before applying to it, it will be completely different once you apply and get a real sense and a value of what it means for these concepts, starting from engineering decision making, time value of money, cash flow analysis, and so on. So all of these are very fundamental concepts, and once you um, refresh your
Sorry,
memory.
Dr. Sorry, Dr. Abdurrahman. Can you please share the other screen because it's this.
Oh, okay. Was I sharing the?
Yeah, the small screen.
Okay, let me see. So is this the correct one?
No.
No, still. And now?
Yes.
Okay, all right. Sorry about that. Thanks, Dr. Muhammad. Um, yeah, for some reason this computer always swaps the screens. So as I was saying, these fundamental concepts are very important and very relevant to your work as an engineer. So that's the interesting thing about the course is it will be very useful to you beyond taking the exam. So as I mentioned, several key concepts. Today, I will just be focusing on one fundamental concept in engineering economics, which is the time value of money. So the time value of money is asking the question, what determines the growth of a $1 over a period of time? So how can we make the trade-off between the value of money today or now and the value of money in 1 year, in 10 years, in 20 years, and so on? And as you can imagine, this is very important and critical in determining the value or the success or the possibility of even embarking on a new project because we need to make sure that we're investing today, our investment today in terms of financial investments or new engineering projects will be worth worth its while and worth more in the future. So to make this trade-off between today's money and the future money, we have what is called the interest rate. So the interest rate encapsulates our understanding of the trade-off of the value of money, and that for this reason, $1 today should be worth more than $1 in the future. And the reason is the opportunity cost of this $1 today. So if you have $1 today, you can use it in multiple ways. You can try to grow it, whether by investing it or by embarking in a project, and it's definitely going to be more valuable than having $1 in the future. So $1 in your hand today is definitely worth more. But how much more? That's the question we want to quantify and want to answer. And our way of doing this is by relying on what we call the interest rate. So the interest rate, think of it as the exchange factor between today and the future. Um, as you can see in the graph, depending on this interest rate or R and the time duration, then the future value will be a function or will depend significantly. It will depend on other factors as well, but it will depend significantly on this interest rate R. And as you can see, going from R equals 0 to 15, you can see a significant difference over the number of years we have in the value or the future value of money. So as we speak about interest, we are mainly interested and we mainly focus on what is called the compound interest, not the simple interest. And the compound interest means that you're going to take your initial value or the capital and then gain some interest on it. And then you're going to compound the interest by adding new interest on that new amount that you have. So let's take one example to make sure we're all on the same page of what I mean by compounding. And let me tell you, this is a very fundamental concept, but if you know it, you already have covered 20% of the exam. So there's always one question in the exam about the time value of money. It's one fundamental equation of the compound interest. Once you know it, the rest of it should be relatively straightforward. So suppose you have $1 today, and we assume that the interest rate is 5%. How much money or what's the value of money you'll have in 1 year? So in 1 year, we know that we're gonna multiply by 105% or 1.05. So this is where the 5% comes in. So after 1 year, you know that your dollar will grow by 5% or 5 cents in this case, it will be 1.05. So what about the second year? So in the second year, remember, you're not starting with the $1, you're actually starting with the 1.05, meaning that you'll take the $1 you had initially and the interest you've gained, and then you're going to compound it again and add the interest, which is now 1.103. And as you can imagine the remaining of the formula, we can keep doing this again and again. You take whatever um, capital or initial value, you add the interest, and then you multiply it by 1 plus r or 1.05 in this case. So you can see this compounding or the exponential growth, which makes it very important to understand and really appreciate how powerful the compounding is. So to put it in an equation, as we like to do as an engineer, we can say that $1 today is equivalent to $1 times 1 plus r to the power of t, where t is the period of time where you expect your money to grow or have interest during that period. Equivalently, if you just inverse the equation, you can say that $1 in t years, how much is it equivalent today? So just the inverse of this value, so it's going to be 1 over 1 plus r to the power t today. So meaning that if you're going to value a project, and this is something we'll discuss in the course, if you're going to value a project in the future, you need to know how much is it worth now. If in the future value is less than its value today based on this formula, then maybe it's not the best project to choose from. So this is the main equation of that represent the compounding time value of money. Once you get a good understanding of this, the remaining will be just applying this concept for the questions. So let's take one example from May 2019. And in most of the exams, the first question is about time value of money. In the exams, you have 5 questions. The first one is on time value of money. So if you get it right, you've already covered 20% of the exam right away. So the question asks about 3 different credit cards or credit card companies that offer different products and charge different interest rates on overdue balance. So you can right away see this example being applied to our daily life if you use a credit card or take a loan or deal with anything that has interest rate in it. How can we calculate it? So we have Silver, Visa, Fast Card, and Mac Express, which charges 24 compounded daily. Fast Card charges 25% compounded weekly, and Mac Express charges 26 compounded monthly. So the first thing to notice right away, beside the difference in the interest rate, is the compound period. So how soon or what's the interval based on which you compound your loan in this case or your interest due on the balance. So in the first one, it compounds daily. So every day you compound it your balance. The first charge compounded weekly, and the last one compounded monthly. So how can we relate all these values? So the first question asks, what is the effective annual interest rate charged by each of the 3 credit cards? So here we show the table that summarizes the interest and the compounding period. And as you can see, because the compounding period is different, then it's not straightforward. How can you compare the products? You need um, one unified way, one unified metric, so you can compare Silver, Visa, and Fast Card. Because 24 compounded daily versus 25 compounded weekly, this has a very different effect on the compounding. So to do that, we know we have what is called the effective annual rate or EER, which may differ from the annual percentage rate. The annual percentage rate in a nutshell, essentially is what the bank or the financial institution or the project manager quotes you. So this is essentially what is the percentage rate on an annual basis. The effective annual rate, this is what actually gonna be the calculation at the end of the year based on the compounding. So all of these interests mentioned in the table are annual percentage rate. This is what the bank is telling you or the credit card is quoting you. The effective annual rate is what we want to calculate to make sure we're comparing the products on equal footing. So the formula for this is very similar to the formula we've seen before, 1 plus r to the power t. The only difference in this case, instead of t, we have n, where n denotes the compounding period. And inside of the parentheses, we have r over n, so we can account for the frequency or the period of compounding of this interest. So essentially, if we want to calculate the effective annual rate, we take R, which is the APR given to us in the question, and calculate it accordingly. So if we just apply the values that we have from the example, and we begin by Silver Visa, you can see here I replaced R with the 24%, or when plugging in the equation, it's 0.24. So this is the 24%. And for the Silver Visa, it's compounding daily, meaning that we need to account of 365 periods in the annual period or in the year. So because we're compounding daily and we are interested in the effective annual rate from the annual percentage rate, we consider 365 periods in that period. 365 days in that period. So if we plug in the calculation, we get right away 27.11%, which as you can see, it differs by 3%, almost 3% higher than the annual percentage rate. And this makes a huge difference when accounting for not only credit cards, but accounting for your projects, and if you're taking a loan for the project and so on. If we apply the same approach to the fast card, if you think about for a second, what will be n in this case? So in the first example, it was compounding daily, and we had 365. So in the second example, it's weekly. So we have 52 weeks in the year, and that's why we take 1 plus 0.25 to the power of 52 over 52. And that gives us 28.33. And then last but not least, monthly, that will be taking to the 12th power and then dividing by 12. And sorry, there's a typo here. This should be 0.26 because we take it on an annual, on a percentage basis. Okay. Any questions so far on the application of the compound interest? Okay. Please feel free to interrupt in any time if you have any questions during the explanation. All right, so the second part of the question B, what is the effective semi-annual rate charged by each of the credit card? So remember the first time we calculated the effective annual rate. Now we just want to calculate the effective semi-annual rate. And the trick here is to make sure you understand what is your n. So remember in the first example, we had a daily compounding for a year, so 365 days or periods. If you want to calculate the semi-annual rate, what would you think be the value of n in this case? So 1 year, 365. So it makes sense for the semi-annual, it will be exactly half of that, so 182.5. Remember, we're calculating the compounding over semi-annual or only for half of the year. So we're compounding it for 182, so we're changing the power, but the number of periods within the year does not change. So that's why we keep the 365 as is. And as you can see, 12.75, which is slightly less than the annual, the effective annual rate because of the compounding that happens every month. Very similarly, for the fast card and the Mac Express, excuse me, which is turned out to 13.2 and 13.72 respectively. Excuse me. Sorry about that. So as you can see, just the same formula, plugging in the annual or the semi-annual rate respectively. Question C, which credit card would you prefer? So if you understand the question I've calculated, you see that because this is a credit card, meaning that you're paying the balance, which means that the interest is working against you. In this case, we try to choose the lowest one, right? We want to pay the lowest balance due at the end of the month. If this was a project and you're trying to see the profits, for example, or what is the expected gains and revenue to come, then we would choose the one with the highest interest rate for our project. So depending on the context, lowest versus highest, but from this example, since we're interested in paying the lowest balance, we choose the silver visa. Last but not least, how much should the interest rate be for silver visa in order to break even with fast card? Again, we're trying to compare different products. The compounding period is different, so we cannot really compare the 24% from Silver Visa with the 25% of Fast Card. So in order to do so, we rely on the effective annual rate, which is effective for both of them, regardless of the compounding period, because we take it into consideration. If we do so, we're trying to see what is the value of the 24 here that we change in order to have the same effective annual rate for both of these products. So if we want to match the silver visa with the fast card, so essentially we want to match this left-hand side of the equation with this right-hand side of the equation of 28.33. So if we do so, we just are looking for this x here, which is the value other than 24%. So it's equal the effective rate of the 28.33 of the fast card. If we do so, if we take 28.33 to the power of 1 over 365 and do our massaging of the equation, we can get 24.95 compounded daily. Which means that if you want to get the card that compounds daily, if it's higher than 24.95, then you're better off with the weekly compounding of 25%. So as you can see here, in order to compare the two products, we rely on the effective annual rate. And all of this calculations and manipulations we can do based on our equation of the compound interest rate that gives us a quantification of the time value of money based on interest rate. So this was for 2019, but once we take a look at the previous exams, for example, in December 2018, you can see it's a very, very similar question. The only difference is that in this case, you're accumulating in a savings account. So you can see, reading the question, it's the same idea of different compounding periods, and you have R, and you want to make sure you understand the difference between the effective and the annual interest rate, whether you're borrowing or saving money. Similarly, in December 2019, if you were lend for a specific amount of a loan for 3 years with a simple interest rate, how would you have at the end of the 3 years? What's the accumulation? And also in May 2017, a very similar question. So I just want to show you that once you get a grasp of the initial concept of the compounding, you'll be able to solve all the different questions relating to the time value of money. So does anyone have any questions on the time value of money or anything related to the engineering economics course in general? Okay, so I realize that some of you may not have any questions now. Please feel free to reach out to us as our contact regarding any of the slide content or any of the course. And I also, for the same for Dr. Muhammad, any of the course in content in general, you can reach out to him. Even if you're not sure you're gonna enroll in the course or not, we'll be more than happy to provide guidance and answer any question you have. So that's it for my part, and thank you.
Thank you, Dr. Muhammad. Thank you, Dr. Abdulrahman. Yeah, this is it about today's webinar. We are a little bit over time today, but we started also like a little bit late. So it's almost 1 hour. Yeah, the last thing here, if you have any questions, feel free to reach us. If you wanna register to any of our courses, also feel free to reach us through our LinkedIn, Facebook, WhatsApp, or our website. We will be happy to answer all questions and help you. Last thing, thank you very much for attending today's webinar and wishing you all the success in your endeavors. Thank you.
Thank you all. Best of luck.
Thank you.